In the quiet hum of the cosmos, beneath the steadfast laws of gravity and light, lies a doomsday switch. It isn't a button in a hidden bunker, nor a countdown timer on a dying star. It is a fundamental instability woven into the very fabric of space-time, a flaw in the source code of reality itself. Our universe, with its 13.8 billion years of cosmic history, its 2 trillion galaxies spiraling in the dark, might be a single quantum fluctuation away from being completely and irrevocably overwritten. This isn't a premise from science fiction. It is a terrifyingly plausible scenario emerging from the cold, hard mathematics of our most successful theory of reality, the Standard Model of particle physics. What if the fundamental constants that orchestrate the dance of atoms, the fusion in stars, and the complexity of life are not permanent? What if they are merely temporary bylaws, held in a delicate, fragile balance that could be shattered by a microscopic glitch? To understand this cosmic peril, we must first redefine our concept of nothing. In classical physics, a vacuum is simply empty space, a void. But in the strange and beautiful world of quantum field theory, the vacuum is the most important thing in the universe. It is not an absence of stuff, but the absolute ground state, the lowest possible energy level that a system can occupy. Think of it as a perfectly still, infinitely deep ocean. Every particle we see, every electron, quark, and photon is just a ripple, an excitation, a momentary splash on the surface of this underlying quantum field. The laws of physics as we know them are a direct consequence of the properties of this vacuum state. It is the stage upon which all of existence plays out. But what if our stage is built on a fault line? What if our calm ocean is actually a pond perched at the top of a colossal waterfall? This is the chilling concept of the false vacuum. Physicists now suspect, based on increasingly precise measurements, that our universe does not reside in the true ground state. Instead, we may be living in a metastable state, a false vacuum. The analogy is simple yet profound. Imagine a vast rolling landscape of hills and valleys representing all possible energy states of the universe. The true vacuum is the deepest valley, the point of absolute stability from which you cannot fall any further. A universe in this state would be eternal and unshakable. Our universe, however, seems to be like a ball resting not in that deepest valley, but in a small, shallow dip on the side of a much larger hill. It's stable for now. A small nudge won't dislodge it. It has allowed for billions of years of cosmic evolution, but it is not fundamentally absolutely stable. There is a lower, more stable energy state it could fall into, the true vacuum valley that lies just over the hill. Classically, a ball needs a push to get over a hill. But in the quantum realm, the rules are different. Here, the universe can cheat. It can exploit a bizarre phenomenon known as quantum tunneling. At the subatomic scale, particles can do the impossible. They can pass through energy barriers they don't have enough energy to overcome. It's as if our ball, without any push, could spontaneously disappear from its shallow dip and reappear in the deeper valley on the other side. For the universe, this tunneling event would be the ultimate catastrophe. Somewhere, in the vastness of space, a microscopic bubble of the true vacuum could spontaneously materialize. This bubble would not be empty. It would be a region of space where the fundamental laws of physics have transformed into their true lowest energy configuration. It would be the universe correcting its own flaw. And this correction would not be gentle. The question this forces upon us is no longer a philosophical musing, but a matter of cosmic survival. What is this universal field that holds our fate in its quantum balance? And have we, in our quest to understand the universe, already measured the evidence of our own precarious existence? Building on that terrifying premise, the key to our universe's potential instability, the very field whose energy landscape we are precariously perched upon, is one you have already heard of. It is the ghost in the machine, the invisible ocean that permeates all of space, the source of mass for every fundamental particle. It is the Higgs field. Its discovery in 2012 at CERN's Large Hadron Collider was a triumph, the capstone of the Standard Model. But within the data that confirmed its existence lies the blueprint for our potential annihilation. The Higgs field isn't just a uniform sea. It has a potential energy shape, a topography determined by its own self-interaction and its relationship with other particles. In the first moments after the Big Bang, the universe was incredibly hot, and the Higgs field was excited, its value at 0. As the universe cooled, it was as if a ball was released onto a surface shaped like the bottom of a wine bottle, a Mexican hat. The ball didn't stay balanced on the central peak. It rolled down into the circular gutter at the bottom. This rolling down was a phase transition that broke fundamental symmetries and gave mass to the particles that make up our world. We live in that gutter. The problem is, our calculations suggest that this gutter may not be the lowest point on the entire energy map. There may be another, far deeper valley beyond a high-energy wall. The fate of our universe hinges on a delicate cosmic tug-of-war between two numbers, the mass of the Higgs boson and the mass of the heaviest known elementary particle, the top quark. The Higgs boson's mass, measured with incredible precision to be around 125 giga-electron-volts, represents its own self-coupling. It acts like a force pushing the potential energy of the vacuum upwards, making it more stable. The top quark, however, with its colossal mass of about 173 GeV, has a strong interaction with the Higgs field that drags the potential energy downwards, especially at very high energies, threatening to create that deeper, more stable valley. The measured values for these two particles place our universe in a truly unsettling position. We are not in the completely stable zone, nor are we in the blatantly unstable zone where the universe should have collapsed long ago. We are balanced on a knife's edge, in a state that physicists call metastable. According to a 2018 paper that incorporates the latest data, the lifetime of our false vacuum is calculated to be astronomically long, many billions of trillions of times the current age of the universe. But this is a probabilistic calculation. Quantum tunneling is a random event. The immense calculated lifetime just means the probability of it happening in any given second is vanishingly small, but it is never 0. It could happen in the next 10 trillion years, or it could happen before you finish this sentence. If it does, a tiny bubble of the true vacuum will form and expand outwards at the speed of light. The wall of this bubble would be a shell of pure concentrated energy, but what happens inside is the true horror. Within the bubble, the Higgs field would have a much larger value. This would fundamentally alter the constants of nature. The masses of electrons and quarks would change, perhaps becoming so large that atoms could no longer form. The W and Z bosons, which carry the weak nuclear force responsible for radioactive decay and stellar fusion, might change their properties so drastically that the force itself would operate over different ranges, or not at all. Chemistry would be impossible. Biology would be a forgotten dream. Stars would be extinguished. The very fabric of reality would be rewoven into a new alien tapestry governed by laws we cannot even imagine. And because the bubble expands at the speed of light, there would be no warning. No telescope would see it coming. It is the ultimate blind side. One moment, a distant galaxy is there. The next, it is consumed by the expanding wall of the new vacuum. Then, in an instant, our solar system, our planet, and you would be erased, overwritten by a new, more stable, and utterly uninhabitable form of existence.
So we live on in a cosmos that is both magnificent and terrifyingly fragile. Our existence is a statistical anomaly, a temporary reprieve from the universe's true ground state. Every star we see, every law we discover, might just be the features of a bubble waiting to pop. The final truth of the universe may not be light and life, but a silent, stable, and utterly empty void. And the most profound question is not whether the universe will end, but whether our brief, improbable existence was ever truly stable to begin with.